Hello everyone, welcome to another math class. Actually, we are going to solve a differentiation question today. So the question is, a curve is given by the equation y equal x to the power 3 minus 3x squared plus 9x plus 5. This is the equation we have given, this one. So it's a function. The function is x cubed minus 6x squared plus 9x plus 5. So what we have to do, these three questions we will cover in this video, these three questions. First of all, we will find the differentiation of this equation, the curve, and second, we will find the stationary point and classify them as local maxima and minima. And the third question is, we'll find the tangent of the curve at the point x equal to 2. So let's dive on. For the first question, the A, we have to find out the derivative of y, I mean the equation, the curve. So let's first differentiate the value, okay? So our equation is y equal to x cubed minus 6 squared plus 9x plus 5. So if we differentiate both sides, so it will be ddx of y equal to ddx of cubed minus ddx of 6 squared plus ddx of 9x plus ddx of 5. I'm showing you step by step, so I write this line for you. So normally you don't have to write this part. So there is ddx of y equal to the derivative of x cubed. So we all know what's the equation, what's the formula of derivative, right? So if I write ddx of x to the power n, what's the differentiation formula? The x to the power n, the power will go on. So let's say that here the base is x and the power is n. So n will come on the first position as a coefficient, and then we just have to subtract 1 from our power. So that's the differentiation value of x to the power n. So what's the value here? Uh, X cubed. So we are going to differentiate x cubed. So the power is 3. 3 will come as different coefficient, and then from 3 we have to take away 1. So this is the formula. From power we have to take away 1. So if we take away 1, it will be squared, right? So the next step, the minus. Here 6 is the coefficient, is the building coefficient for here. So we keep it as it like, and there the power is 2. So 2 will come as coefficient. So if 2 is come as coefficient, so it will be it going to times with 6, right? So 6 times 2 is 12, and then we have to take away 1 from power. So from 2, if we take away 1, it will be 1. So we don't have to write 1 as a power. So it's 6x. So 12x plus here in the third part, 9x. So 9 is the coefficient. So we keep it as it is. And what's the power of x? The power of x is 1. Because whenever there is nothing written on the power, we have to keep say it's 1. So 9 as coefficient, it was there, and x to the power 1. So if we take away 1 from 1, it will be x to the power 0. And what's the x to the power 0? X to the power 0 is 1. So we will write 1. And what's the value of constant? If we derivative any constant, it will be 0. So we don't have to write 0, right? So the equation is, I mean, the derivative of the curve we given in the question, y equal to x cubed minus 6 squared plus 9x plus 5 is 3x squared minus 12x plus 9. Here's the answer of our first question, the derivative of the curve. It's just one line question. So uh, we already solved it. Let's dive in the second question. Okay, for the second question, they say determine the coordinates of the stationary points and classify them as local maxima or minima. So let's say for B, uh, let's say did x of y equal to 0, because we have to find the value of x for, I mean, the stationary point. So otherwise we won't find the maxima and minima. So did x of y equal to 0. So what's the did x of y value? From A, we got the differentiate value. So that was 3x squared minus 12x plus 9, which is 0. If we, from this, we will, by factorizing, we are going to factorize it. Factoring, actually. So by factoring, we'll get 3 times x minus 1 times x minus 3 equal to 0. And from here, we can say x equal to 1 and x equal to 3. These are my stationary point. These are my stationary points. So we already get our stationary point. So we will classify our stationary point to find the maximum and minimum. So for classify this value, we have to find the double derivative of this value. So I mean second derivative for, let's go for second derivative. Second derivative is x squared y d square y dx squared equal to, if we derivative this part again, what it will be, the power will come to the front, right? So it will times with the coefficient. So if we times it 6 and the power is 2, so it will if we take away 1, so it will be just x, and minus it will be 12 because the power of x is 1, right? So 6x minus 12 is our second derivative. So we will plug in our stationary points in second derivative to get local maxima and minima. So if we plug in x equal to 1 to our second derivative, it will give 6 times 1 minus 12 equal to minus 6, which is negative. And we know for negative value, we'll get local maxima. And let's plug in our second value. Our second value of x is 3, the x 3. So put in value in second derivative. So 6 times 3, take away 12 is positive 6. So it's positive. If we get positive value, we'll get local minimum. So for we can say for x equal to 1 is a maximum, and for x equal to 3 is a minimum. That's the answer we got from second one. And now the third question is find the equation of the tangent to the curve at x equal to 2. So in the value of x equal to 2, we have to find the tangent. So let's see how we solve the question. So now let's find the question like at tangent at x equal to 2. First, we have to find y at x equal to 2. So we have to find y at x equal to 2, right? So if we plug in our value, I mean x equal to 2, to our main curve, this one, then we will find the value of y, right? So y2 is equal to 2 cubed minus 6 times 2 squared plus 9 times 2. 9 times 2 plus 5. So which is 8 minus 24 plus 18 plus 5, which is 4. This is our value. And now we have to find the gradient of at x equal to 2. So to find the gradient at x equal to 2, we have to put our value x equal to 2 at our first derivative. Where is our first derivative? Our first derivative is 3x squared minus 12x plus 9. Here it is. So x equal to 2 at first derivative. So dx of y equal to 3 times 2 squared minus 12 times 9. Sorry, 12 times 2 plus 9. So here 12 minus 24 plus 9, which is minus 3. So our first derivative value is negative 3. So we are going to, which is the gradient, right? So at x equal to 2, the gradient is 3. And we have to find the equation of tangent at x equal to 2. So what is the equation of tangent? Equation of tangent is a straight line, right? So, and it's going through one point. So now we are using formula of tangent, using the tangent line formula. So what is tangent line formula? Take away y1 equal to m times x minus x1. So this is the tangent line formula for, I mean, along one point. So what's the value of x1 and y1? So x1, we already get our values. Y is equal to 4 and x is equal to 2, right? So y minus 4 equal to, we get our gradient at x equal to 2 point, which is minus 3. So m minus 3, x minus x1 is 2, so minus 2. So we will get here y minus 4 equal to minus 3x, minus 3 times minus 2 is plus 6. So we'll get y equal to minus 3x plus 10. So this is our equation of tangent at that value. uh, I mean, the equation of tangent to the curve at x equal to 2. So we differentiate the function. First of all, this is the curve. We got the equation of curve, y equal to x cubed minus 6 squared plus 9 plus 5. We differentiate the function. At equation A, we get our differential value. In second equation, we found stationary point at x equal to 1, maximum, and at x equal to 3, minimum. And at C, in the last question, we derive the tangent at x equal to 2 as y equal to minus 3x plus 10. If you found this helpful, you don't have to share, subscribe my video, I mean channel. Just learn things, and if you have any questions, just comment there. So see you in the next video. Thank you.